Good day, I'm Bobby, and I'm excited to showcase the new vector graphics capabilities of our powerful XGSLab software. Renowned for its precision and efficiency, XGSLab is trusted by our customers for its exceptional performance in engineering applications, including earthing, electromagnetic field interference, EMFI, cathodic protection, split current calculation, shielding, and lightning protection. These cutting-edge vector graphics bring unparalleled clarity and detail to our calculation results, as you can see in the attached examples, earning widespread admiration for their professional quality and ease of interpretation. Please also take a moment to listen to the Talkback show, where James and Shelley dive deeper into how XGSLab continues to revolutionize the industry with its innovative features.
All right, so you sent over a bunch of documents about this XGSLab software.
Okay.
And honestly, I'm a little intimidated.
What?
We've got like this thick user guide and a marketing presentation full of like lightning strikes and graphs.
Mm-hmm.
So what exactly are we getting into with this XGSLab thing?
Well, it seems like you've stumbled into the world of grounding systems.
Okay.
XGSLab is a tool that engineers use to make sure those systems are doing what they should be doing.
And what's that?
Basically, to keep electricity flowing where it should,
Mm-hmm.
and more importantly, keeping it away from where it shouldn't.
Okay, that makes sense. But why all the fuss about grounding?
Hmm.
Like I flip a light switch, the light turns on.
Right.
What's happening behind the scenes?
Think of it like plumbing.
Okay.
They need pipes to bring water into your house,
Right.
but you also need drains to take away the excess.
Yeah.
Grounding systems are like those drains for electricity.
Interesting.
They give a safe path for stray currents to flow back to the source, which prevents shocks and protects equipment from damage.
Okay, so it's like a safety net for our electrical systems.
Exactly.
Never really thought about it that way. But I'm looking at the materials here, and this XGSLab software seems pretty complex.
Yeah, it is a sophisticated tool.
Yeah.
It lets engineers analyze these systems in really detailed ways.
Like how detailed are we talking?
It takes into account things like soil properties,
Yeah.
conductor types,
Uh-huh.
even things like lightning strikes.
Whoa, lightning strikes.
Yeah.
So we're not just talking about preventing little shocks here.
Nope.
We're talking about protecting against forces of nature.
Exactly. And the consequences of not doing it right.
Oh, no.
They can be pretty serious.
Like what could happen?
You could have fires,
Oh, wow.
equipment failure,
Okay.
even injuries, or worse.
So this is really important stuff.
Yeah, that's why engineers need specialized tools like XGSLab to make sure these systems are designed and installed properly.
That makes a lot of sense. So who are the people using XGSLab?
Primarily electrical engineers.
Okay.
They design and maintain all sorts of electrical systems,
Like what?
power grids,
Okay.
renewable energy installations, even the wiring in your own house.
So you're saying the engineers that keep the lights on in our cities are using this software?
Pretty much anyone working with electrical infrastructure needs to understand grounding systems.
Wow, that's pretty important work. But I'm still not quite clear on why grounding is so complex.
Yeah.
Can you give me an example of what could go wrong if things aren't done right?
Okay, imagine a power surge during a storm.
Okay.
If the grounding system isn't designed correctly,
Yeah?
that surge could travel through like metal pipes in your house,
Uh-oh.
energizing your plumbing.
Oh,
And anyone who touches a faucet could get a shock.
yikes.
Yeah.
Definitely don't want that to happen. So XGSLab helps prevent that by letting engineers analyze the system and making sure it can handle those kinds of situations.
Exactly. XGSLab lets engineers simulate all sorts of real-world conditions,
Like what?
like lightning strikes, ground faults,
Mm-hmm.
changes in soil moisture,
Wow.
and it helps them understand how the system will respond.
All right, so now that we've got a handle on the basics,
Go.
let's dive into some of the specifics about XGSLab.
Sounds good.
What are some of the things that stand out to you from these materials?
One of the things that surprised me was how much emphasis XGSLab puts on analyzing the soil.
Really?
Yeah, it turns out the ground itself plays a huge role in how well a grounding system works.
Wait, so it's not just about the wires and rods that are buried in the ground?
Nope.
The dirt itself matters.
Oh yeah, the soil acts as a conductor,
Huh.
and its properties can vary a lot
In what way?
depending on the location,
Okay.
moisture levels,
Mm-hmm.
even the time of year.
Wow.
XGSLab takes all of that into account.
Okay.
It analyzes things like soil resistivity,
Uh-huh.
permittivity,
Okay.
and even layering.
I had no idea there was so much to consider just with the ground itself. What else stood out to you?
Well, XGSLab offers different modules for specific tasks.
Oh, like what?
There's the basic GSA module,
Okay.
but then there are more advanced options like GSEF,
GSATB.
XGFD, and others.
Okay.
Each one is designed for analyzing different aspects of the system.
So it's not a one-size-fits-all solution.
Right. It's more like a toolkit for tackling different grounding challenges.
I'm guessing those different modules are meant for different types of installations and scenarios then.
Exactly. GSAFD, for example, is specifically designed for handling higher frequencies,
Okay.
which is important when you're dealing with things like lightning strikes.
Right.
And then you have modules like XGSAFD,
Yeah.
which are used for analyzing complex systems with both underground and overhead conductors.
So like you might find at a power plant or something.
Exactly.
Okay, now I'm really starting to understand the scope of this software. It's not just about basic grounding principles.
Yes.
It's about analyzing all these different scenarios and using the right tools for the job.
Exactly. And XGSLab doesn't stop there. It also uses some pretty cool techniques to visualize the grounding system.
Visualize it.
Yeah.
What do you mean?
It can create maps,
Okay.
graphs, even 3D models that help engineers see what's happening underground.
3D models. That's pretty impressive. I'm starting to see why this software is so powerful, but I'm also realizing this is a lot more complex than I initially thought.
It is, but it's really interesting stuff. And in the next part, we can talk more about those visualizations,
Okay.
as well as some of the more interesting details we found in these materials.
Sounds good. I'm ready to keep learning more about XGSLab.
All right, let's do it.
Okay, so last time we talked about how XGSLab is kind of like a Swiss Army knife for electrical engineers,
Yeah.
helping them make sure that all the grounding systems are doing their job. I'm still kind of wrapping my head around how complex all of this is.
Yeah, it is pretty involved.
Where do we even go from here? What else can this software do?
Well, we talked about the visualizations a little bit last time.
Right.
And I think that's a good place to start. Because honestly, trying to make sense of a grounding system
Yeah.
just by looking at like numbers and equations,
Yeah.
it would make my head spin.
I might too. I'm definitely a visual learner.
Okay, well, good.
Yeah.
Because XGSLab can create all kinds of visuals,
Like what?
like contour maps.
Okay.
They show how the voltage varies across a site,
Okay.
graphs of like touch and step voltages,
Uh-huh.
which are really important for safety.
Right.
And it can even create 3D models of the entire grounding system.
Wow, so it's like having X-ray vision into the ground. You can see how the electricity is flowing and where the potential hazards are.
Yeah, exactly. And that's really helpful for identifying problems,
Right.
optimizing designs,
Yeah.
and even just like communicating the findings to people who maybe aren't engineers themselves.
Like clients.
Yeah, exactly.
So it helps make it clear to everyone involved.
Right.
Okay, that makes sense. We also talked about how the soil itself is like a big factor in how well the grounding system works. Does XGSLab do anything specific to account for that?
Yeah, it definitely does.
What does it do?
Remember how we talked about the soil properties, like how they change from place to place?
Yeah.
Well, XGSLab can create what's called a multi-zone soil model.
Okay.
It's like it draws a map of what's going on underground.
So instead of just assuming that the soil is the same everywhere,
Right.
it can take into account all of the variations.
Exactly. And that means the analysis is much more accurate
Okay.
and the designs are safer.
That's good. Now, there was something in the user guide that really caught my eye.
Oh, yeah. What was that?
It was something called the rolling sphere method.
Oh, yeah.
It sounds a little too simple for something as unpredictable as lightning.
I know, it does sound kind of simple,
Yeah.
but it actually is surprisingly straightforward.
Okay, so how does it work?
Basically, imagine a sphere.
Okay.
The size of it depends on the characteristics of a typical lightning strike.
Okay.
And you basically roll this virtual sphere
Mm-hmm.
over a structure that you're trying to protect. Any point that the sphere touches,
Yeah.
that's considered a place that could get hit by lightning.
Oh, okay. So it helps to visualize where the lightning could strike.
Exactly.
And then engineers can use that information to figure out where to put things like lightning rods
Right.
to protect the structure.
Exactly. And XGSLab has this method built into it,
Oh,
particularly in the Shield and Shielda modules.
okay.
Those are specifically focused on lightning protection.
So it's like XGSLab is helping engineers to outsmart Mother Nature,
Haha. In a way, yeah.
at least when it comes to lightning.
It's all about predicting potential hazards and designing systems that can handle them.
Okay, now we've talked a lot about those different modules, like GSA and GSA-FD.
Yeah.
But how do engineers know which module to use, like for a particular project?
That's a good question. It really just depends on how complex the grounding system is
Okay.
and what kind of analysis needs to be done.
Okay.
Like GSA is usually a good place to start,
Okay.
especially for projects that are mainly focused on those lower frequencies.
Right.
But if you need to look at higher frequencies, like we see with lightning or those fast transients,
Yeah.
then you need to use something like GSFD.
So it's like choosing the right tool for the job.
Exactly.
GSA for the more basic stuff.
Right.
And GSA-FD when you're dealing with the more extreme cases.
Exactly. And then there are modules like XGSAFD
Right.
that are even more specialized.
What do those do?
Those are for analyzing systems that are super complex.
Okay.
Like they have both underground and overhead conductors.
So it's like XGSLab has a tool for every occasion.
Pretty much, yeah.
But what is it about those higher frequencies that make them so difficult to deal with?
That's a good question.
Yeah.
Well, at those lower frequencies,
Yeah.
it's mostly about the resistance.
Okay.
The resistance of the conductors in the soil.
Okay.
But when you start dealing with higher frequencies, other things start to matter more.
Yeah.
Like the inductance and the capacitance.
Okay.
It's kind of like the rules of the game change.
Yeah.
And you need more sophisticated tools to analyze what's happening.
So it's not just about how much electricity is flowing.
Right.
It's also about how quickly it's changing direction.
Exactly. That's
Wow.
a great way to put it. And that's why those modules like GSAFD are so important.
Okay.
They use these advanced techniques,
Like what?
like the finite element method,
Okay.
to really accurately model what happens at those higher frequencies.
To make sure that the grounding system can actually handle it.
Exactly.
Now, speaking of handling things, the user guide talked about doubtful separations
Oh, no.
during the design process. What does that even mean?
So during the design phase,
Yeah.
engineers have to define all the connections and separations between all the different parts of the system.
Oh, okay. And what could go wrong there?
Sometimes those separations,
Yeah.
they might be too small,
Okay.
or maybe it's not totally clear exactly where they are,
Okay.
and that could lead to like unintended connections or problems with how the system performs.
So it's like a little gap in the blueprints
Right.
that could cause a bit headache later on.
Yeah, exactly.
But XGSLab can find those doubtful separations
Uh-huh.
and it'll flag them for the engineer to double check
Right.
to make sure that everything is how it should be.
Exactly. It's like having a second set of eyes
Yeah.
that's really good at catching mistakes.
Okay, so XGSLab is like that super attentive coworker
Uh-huh. Yeah.
who always catches your typos before you send that email.
Exactly. And speaking of attention to detail,
Yeah.
there's another concept that I think is worth talking about.
Okay, what's that?
The idea of victims and sources.
Victims and sources. That sounds kind of ominous.
I know, right?
What are we talking about here?
Think about like a river.
Okay.
The source of the river is like the spring where the water flows from.
Okay.
And then the victims are like the towns downstream
Okay.
that are affected by that flow.
So in a grounding system,
Yeah.
what would be the source and what would be the victims?
So the sources
Yeah.
are the parts of the system where the voltage or the current is already known,
Okay.
like a power line or a generator.
Okay.
And the victims are all the conductors that are influenced by those sources.
So basically anything that could be affected by how the electricity flows.
Right?
So it's kind of like XGSLab is figuring out how that electrical river is going to flow
Uh-huh.
and making sure that it doesn't flood any of the towns along the way.
Yeah, that's a great way to think about it.
To make sure that everything is safe.
Exactly. And it also makes sure that each conductor is categorized correctly.
Okay.
So the calculations are accurate and the design is as safe as possible.
Now, all of this is really fascinating.
It is cool stuff.
But I have to admit, it's a little overwhelming, too.
I know it's a lot to take in.
There are just so many things to consider.
Yeah.
From the soil to the conductors to all the different types of analysis.
Right.
How do engineers even keep track of it all?
Well, that's one of the things that XGSLab does really well. It gives engineers like a framework
Okay.
to organize all that information. And it breaks those complex problems down into smaller steps.
So it's not just like entering numbers into a computer and hoping for the best.
Right. It's not a magic box.
Okay.
It's a process
Yeah.
that helps engineers to approach these problems systematically.
So the user guide actually walks you through that entire process.
Yeah, it does.
Okay, so what does that look like?
Well, it starts with defining the project,
Okay.
like all the parameters.
Uh-huh.
Then you choose the right modules,
Right.
and then you input all the data.
And the guide helps you do all of that.
It does, and each step builds upon the previous one.
Okay.
So in the end, you have this really comprehensive analysis of the grounding system.
So for example, the user guide talks about how to define the soil model.
Yeah.
And how to take into account things like layering and resistivity.
Right.
And even things like how the moisture levels change throughout the year.
Exactly. It's pretty detailed.
So once the soil is defined, and you've chosen the modules, and you've put in all the data, what happens next?
Then XGSLab takes all that information,
Okay.
it crunches all the numbers,
Mm-hmm.
and it generates a bunch of results.
Okay.
And those results can be shown in different ways,
Oh, like how?
like in tables
Okay.
or graphs,
Mm-hmm.
or even those 3D visualizations that we talked about.
Right, to make it easier to understand.
Exactly.
And I'm guessing those results cover all sorts of things,
They do.
like safety considerations and making sure the grounding system is working as well as it can.
Absolutely.
Right.
XGSLab can calculate touch and step voltages
Okay.
to make sure that they're safe.
Right.
And it can see how the current is flowing through the system
Okay.
and even check how well the lightning protection is working.
Wow. So it's like a virtual lab
Yeah, it is.
where engineers can test out all sorts of scenarios.
Without having to actually build anything physically.
Yeah, that's really cool. It's amazing how much insight you can get from this software.
It really is.
So engineers can use XGSLab
Yeah.
to see what would happen if there were a fault in the system,
Uh-huh.
or if the soil properties changed,
Right.
or even if the amount of electricity flowing through the system increased.
Exactly. It's a really powerful tool for planning for the future.
Okay, I'm convinced. XGSLab is definitely a game changer for electrical engineers. But before we wrap up this part of our deep dive,
Right.
I want to go back to some of those interesting details that we found in the user guide.
Sounds good. What did you have in mind?
Well, the guide mentioned frequency dependence. Can
Yeah.
you remind me what that means? Like in the context of grounding systems?
Sure. So basically it means that the way electricity behaves,
Yeah.
it changes depending on the frequency of the current.
Okay.
So at lower frequencies, like what we see in most power systems,
Okay.
the resistance is what matters most. The resistance of the conductors and the soil.
Okay.
But at higher frequencies,
Yeah.
like when you have a lightning strike
Right.
or those fast transients,
Mhm.
other things become important too, like the inductance and capacitance.
Okay, so it's not just about the amount of electricity.
Right.
It's also about how quickly it's changing direction.
Exactly.
Yeah.
And that can really affect how the grounding system behaves.
So XGSLab takes that into account
It does.
with its fancy models and calculations
Yeah, that's due.
to make sure that the results are accurate no matter what the frequency is.
Right.
That's pretty impressive. And I remember another detail from the guide.
Okay.
It mentioned that XGSLab can work with those multi-zone soil models, the ones that we talked about earlier. Can you remind me why those are so important?
Yeah, so it's all about representing how the soil properties actually vary
Okay.
in the real world.
Yeah.
Like with the multi-zone soil model,
Uh-huh.
you can define different areas of the site,
Okay.
and each area can have different characteristics.
So instead of just assuming that the soil is all the same,
Right.
which probably never actually happens,
Yeah, it's very rare.
XGSLab can be more precise.
Exactly. It can take into account all those variations.
Okay.
And that leads to much better designs.
It seems like analyzing these grounding systems, it's kind of like putting together a giant puzzle.
Uh-huh. I like that analogy.
And then XGSLab is the tool that helps engineers do that.
It helps them put all the pieces together.
The soil, the
Yeah.
conductors,
Oh, yeah.
the electrical loads, all the potential hazards,
Right.
and figure out how it's all going to work together.
Yeah, it's a complex system.
Well, I feel like we've covered a lot of ground here today.
Uh-huh. I see what you did there.
Pun intended.
Yeah.
But there's one more thing about XGSLab that I want to learn more about.
Oh, yeah. What's that?
The user guide mentions something called the corona effect.
Oh, yeah, the corona effect.
What is that, and why does it matter for grounding systems?
So the corona effect
Yeah.
is something that can happen around high voltage conductors.
Okay.
Basically, imagine tiny sparks escaping from those wires.
Okay.
That's kind of what the corona effect is like.
So it's like mini lightning bolts coming off of the conductor.
Yeah, kind of.
But why does that happen?
It happens when the electric field around the conductor is really strong.
Okay.
So strong that it actually starts to ionize the air around it.
Wow. So the electricity is basically interacting with the air.
Exactly.
Okay. And is that a good thing or a bad thing?
It can be both, actually.
Yeah?
Like it can cause energy loss
Okay.
and radio interference.
Oh.
And it can even make noise.
So that's not good.
But sometimes it can be helpful.
How so?
Like it can reduce the stress on the insulators.
Okay.
So it really depends on the situation.
So XGSLab helps engineers to figure out
Oh.
whether the corona effect is going to be a problem or not.
Exactly. It has a special tool for analyzing it.
Okay.
So engineers can see how strong the electric field is and predict whether those sparks are likely to happen.
And then they can make sure that the grounding system can handle it.
Right.
This is all so complicated.
I know it is a lot.
My brain is starting to hurt a little.
Well, grounding systems are definitely complex.
Yeah.
But that's why we have tools like XGSLab.
Yeah, to help us make sense of it all.
Exactly. And in the next part, we can talk about some of the even more advanced features of XGSLab.
Okay.
And the specialized modules that it has.
Sounds good. I'm ready to learn more. Last time we were talking about the corona effect and how XGSLab can help engineers to figure out if it's going to be a problem.
Yeah, it's a pretty interesting phenomenon.
It really is. It just shows how many different things engineers have to think about when they're designing these grounding systems.
It's definitely not a simple task.
No, it seems like there's a lot more to it than just sticking some wires in the ground.
Absolutely.
Oh.
There's a lot of science and a lot of analysis that goes into it.
And it seems like XGSLab is the tool that helps them do it all. But there's still more to learn about this software.
There is.
The user guide mentions some even more specialized modules, like beyond GSA and GSAFD.
Right.
Can you tell me about those?
Sure. So remember we talked about those higher frequencies?
Yeah.
How they can complicate things?
Right, like with lightning.
Exactly. That's where those specialized modules come in.
Okay, so which ones are we talking about?
So there's one called XGSAFD.
Okay.
It's specifically for analyzing those complex systems
Okay.
that have both underground and overhead conductors.
So like at a substation or a power plant.
Exactly.
Okay. So when you've got that kind of setup, with all those wires and equipment, both above and below ground, you need a tool that can really handle all of that.
Yeah, you need something powerful.
So XGSAFD can do that.
It can even handle things like screened conductors.
It's screen conductors.
Yeah, those are conductors with multiple layers of insulation and shielding.
Okay. So it's even more complicated.
It is. It adds a whole other level of complexity to the analysis.
So it sounds like XGSAFD is what you need for those really big installations.
Yeah, it's a good choice for those.
Where everything is interconnected.
Right.
Okay, and what about those sudden bursts of energy, like lightning strikes?
Yeah.
Or those switching operations that we talked about?
Well, there's another module called XGAARD.
Okay.
And that's specifically for what we call time domain analysis.
Time domain analysis.
Yeah.
What is that?
So basically, it means that we're looking at how the system responds over time.
Okay, why is that important?
Well, think about a lightning strike.
Okay.
It's not like a constant flow of electricity.
Right.
It's a really short burst.
Yeah, like a sudden surge.
Exactly. And to really understand how the grounding system is going to handle that, we need to look at what happens over time.
Okay.
Like how the voltage and current change.
Like a slow motion replay.
Yeah, that's a good way to think about it.
So you can see what's happening at each moment.
Exactly. And that level of detail, it's really important for making sure the system can handle those surges safely.
To protect the equipment and the people nearby.
Right.
This is all so complex.
It is. It's a lot to take in.
I'm starting to realize just how much work goes into keeping our electrical infrastructure running smoothly.
It's definitely a hidden world for most people.
Yeah, most people don't even think about it.
But it's really important.
Yeah, because without these systems, our modern world wouldn't be able to function.
We'd be in trouble.
And it seems like XGSLab is playing a big part in making sure that everything works as it should.
It definitely is.
This has been a really interesting deep dive.
I'm glad you think so.
Yeah, I feel like I've learned a lot.
It's fascinating stuff.
It is. I think we've gotten all the information we can out of these materials.
I think so, too.
We've covered everything from the basic principles of grounding to the really advanced features of XGSLab and all the things that engineers have to deal with when they're designing these systems.
It's a lot.
It is. When we started, I was a little intimidated.
I know it can seem overwhelming.
All the technical terms and all the complexity.
Yeah, but I think we did a good job of breaking it down.
We did. You explained it all really well.
Both are.
And I think I have a much better understanding of what electrical engineers actually do now.
That's great to hear.
Especially the ones that work on grounding systems.
It's really important work.
It is. And it's something that most people don't even realize is happening.
It's definitely behind the scenes, but it's essential.
Exactly. Well, I think this is a good place to wrap things up.
I agree.
Thanks for taking the time to explain all of this to me.
It was my pleasure.
And to all our listeners out there, thanks for tuning into The Deep Dive. We'll be back next time with another deep dive into a fascinating topic. Until then, stay curious.